Greetings and welcome to the Introduction to Astronomy. In this episode of New Discoveries in Astronomy, we will talk about how lunar soil has revealed an unexpected connection between the Sun, Earth, and Moon. So let's get started. How can the Moon tell us something about Earth's magnetic field? At first, that sounds surprising. The Moon has no global magnetic field of its own, yet scientists discovered that its two hemispheres preserve different records of the solar wind. Those differences were revealed by samples returned from China's Chang'e 6 mission. And they suggest Earth's magnetic shield has been quietly influencing what becomes recorded on the Moon's surface. The Sun continuously releases a stream of charged particles known as the solar wind. Because the Moon has almost no atmosphere and no global magnetic field, those particles strike the lunar surface directly. But Earth's magnetic field changes that picture. As the Moon orbits Earth, the side facing Earth can sometimes encounter solar wind that has already been slowed within Earth's magnetic environment. Meanwhile, the far side remains exposed to the faster, undisturbed solar wind. That means the Moon's two hemispheres experience slightly different space environments. The breakthrough came from material returned by the Chang'e 6 mission. For the first time, scientists could directly compare the soil from the Moon's far side with samples collected from the near side. Researchers measured noble gases trapped inside the lunar soil. These gases were delivered by the solar wind over billions of years. The results showed that particles reaching the far side penetrated deeper into the regolith than those reaching the near side. That difference is exactly what scientists would expect if the far side received faster, more energetic solar wind. The implanted noble gases became more than just chemical measurements. They became evidence. Scientists concluded that Earth's magnetosphere slows a portion of the solar wind before it reaches the Moon's near side. That changes how deeply the particles become embedded in the lunar soil. Rather than observing Earth's magnetic shield directly, researchers are reading the long-term record preserved inside the Moon itself. This is another example of astronomy relying on measurement, inference, and evidence rather than direct observation. The discovery reveals that the Moon is more than a silent companion to Earth. It is also a natural archive. Because noble gases remain trapped in the lunar soil for immense periods of time, they preserve evidence of how the solar wind interacted with Earth's magnetic environment. Future lunar samples may even help scientists reconstruct how Earth's magnetic shield has changed over geological time. We often think of the Moon as preserving the history of its own surface. This study reminds us that it has also been preserving part of Earth's history. Invisible particles from the Sun, shaped by Earth's magnetic field, become tiny clues locked inside the lunar soil. By learning how to read those clues, scientists are uncovering a long and subtle conversation between the Sun, Earth, and the Moon. So that concludes our discussion on how the Moon records Earth's magnetic history. We'll be back again next time for another new discovery in astronomy. So until then, have a great day, everyone, and I will see you in class.